This is our third video for Chapter 9, and in this one we're going to talk about how to come up with your conclusions in hypothesis testing. We'll also talk a little bit about Type 1 and Type 2 errors. When we're doing hypothesis testing, we always test the null hypothesis. When we have our test information, then we can state our initial conclusion. It's always going to be one of these two: either reject the null hypothesis or fail to reject the null hypothesis. There are two ways that we can do this. To make our decision, one thing we can do is use the p-value method, and we already have our significance level alpha, and when we find our p-value, if the p-value is less than or equal to alpha, then our initial conclusion is to reject the null hypothesis. If the p-value is greater than alpha, then our initial conclusion is fail to reject the null hypothesis. If we're using the traditional method, then we would find our critical values and draw a picture, shade in our critical region. Then we look at our test statistic. If the test statistic would be in the critical region, our conclusion is to reject the null hypothesis. If the test statistic is not in the critical region, then we fail to reject the null hypothesis. Let's look at some examples. With our example about the weight of airline passengers, we already found all this information. And just to remind you, the original claim was that the mean weight of airline passengers was less than 195 pounds. So we want to think about our initial conclusion, which is just either reject H0 or fail to reject H0, and also our final conclusion, which we will write in English in terms of the original claim. So if we're looking for our initial conclusion, then there are two ways that we can do this. If we're doing the p-value method, then we're comparing the p-value that we found with alpha. P was 0.0339, alpha was 0.05, and 0.0339 is less than 0.05. That's p and that's alpha. So we have that p is less than alpha. And in that case, our initial conclusion was that we reject the null hypothesis. Now, if we're looking at our traditional method, in this one we would use the critical value. So in this one we would draw a picture. So here's our standard normal distribution, sort of, and our critical value was negative 1.645. And remember, right in the middle of the standard normal distribution we have 0. So our critical value would be over here, and our critical region is anything in the tail past that. So there's our critical region. And then we look at our test statistic, which was negative 1.826. We just want to know which side of this critical value it's on. In this case, it would be to the left of that. So right about here would be our test statistic. Since it's in the critical region, that would also tell us to reject our null hypothesis. Now, to write our final conclusion, if we're rejecting the null hypothesis, that means that we have enough evidence to support our claim, because our original claim in this case was our alternative hypothesis. So we have enough evidence to support our alternative hypothesis. So that means that we have sufficient evidence to support the original claim that the mean weight of airline passengers was less than 195 pounds.
Okay, here's another example. This is the one about the workers getting their jobs through networking. We already had our hypotheses and a test statistic of z equals 1. We were testing with a 0.1 significance level, and this was a right-tailed test, and we had our critical value and a p-value. The original claim for this one was that most workers get their jobs through networking. So first, our initial conclusion that concerns the null hypothesis. If we look at our p-value of 0.1587 and our significance level of 0.1 and compare those two, the p-value is bigger than alpha. And that tells us that our conclusion is fail to reject the null hypothesis. If we do this with the traditional method, then we draw our picture of the normal distribution and put our critical value of 1.28 in there. Here's our picture of the critical region, which is shaded. And then we look at where our test statistic is in comparison to this. Since our test statistic is 1, it's actually between 0 and our critical value, which means it's not in the critical region. And that also tells us that our conclusion is fail to reject the null hypothesis. Now, for our final conclusion, we want to go back to what the original claim was. Our original claim was that most workers get their jobs through networking, and this became our alternative hypothesis. If we're failing to reject the null hypothesis, that means that there's not enough evidence to support the alternative hypothesis. So there's not sufficient evidence to support the claim that most workers get their jobs through networking. One more example. This was from our example with the echinacea treatment, and this one was a little bit different because our alternative hypothesis was not the claim. The claim was that echinacea has no effect on the duration of cold symptoms. So in this case, our claim actually became our null hypothesis. In this one, we ended up with a very, very small p-value. So when we look at our initial conclusion that has to do with the null hypothesis, our p-value is this very small number. Our alpha was 0.01. When we compare those two, the p-value is definitely going to be smaller than alpha. So this says that our conclusion would be to reject the null hypothesis. When we look at this with the traditional method, since our alternative hypothesis had a not equal to, that means we have a two-tailed test. We actually had two critical values, negative 2.6 and positive 2.6, and our critical region is actually both of the tails beyond both of those two critical values. So if we look at our test statistic was negative 5.983. It's clear over here, so it's definitely in the critical region, and that again tells us to reject the null hypothesis. Well, in this case, if we're rejecting the null hypothesis, that means that we're not supporting the claim, because the claim was the null hypothesis. So in other words, the evidence is pointing to the fact that the echinacea treatment might actually have some effect. So the average duration of the symptoms is different than 14 days. Now, one thing about this, it doesn't actually tell us whether the duration is shorter than 14 days or longer than 14 days if all we have is the conclusion of our test. A little bit about type 1 errors, but again, this is the mistake of rejecting the null hypothesis when it is actually the true one, and this is represented by alpha. When we talk about a type 2 error, this is the other mistake. This is the mistake of failing to reject the null hypothesis when it is actually false. If you see beta, this is what we use to represent the probability of a type 2 error. So here's kind of the way this works. If up here across the top we have reality, or what's the true state of nature, so either our null hypothesis is really true or our null hypothesis is really false. Over here is the decisions we get from our hypothesis test. So we either decide to reject the null hypothesis or we fail to reject the null hypothesis. So our type 1 error is when these two intersect. So when our null hypothesis is true, but we reject it. And our type 2 error is this one over here, when the null hypothesis is false, but we don't reject it. Here's an example. We're conducting a hypothesis test of a claim about a gender selection method, which is supposed to increase the likelihood of a baby girl. So that would make the probability of having a baby girl greater than 0.5. So we have our null hypothesis and our alternative hypothesis. So a type 1 error for this would be if we reject the null hypothesis, so if we say that we have enough evidence to support the alternative hypothesis, when actually the null hypothesis is the one that's true. And our type 2 error would be the opposite if we fail to reject the null hypothesis. So if we're saying there's not enough evidence to support the claim that the gender selection method increases the chance of having a baby girl, but it really does.